last paper of the Georges Lemaitre session, and we'll then focus really on Monseigneur Lemaitre with Thomas Hertog talk on the figure and legacy of Monseigneur Lemaitre.
Okay, thank you. Well, it's an honor to commemorate Georges Lemaitre at this academy where he found so much a home. In fact, Lemaitre told us, le monde est une belle histoire, que chaque génération s'efforce d'améliorer. In that spirit, I thought I'd take the occasion to provide a little context behind his pioneering contributions to cosmology, which, as you will see, in many ways laid the foundation for many of the ideas that we heard about this afternoon, and which perhaps indirectly also provides an understanding of his presidency of this academy. So, to set the scene, the history of relativistic cosmology can roughly be divided into 6 periods, going from the initial exploration by Einstein and Willem de Sitter in 1917 to the precision science we have today. Lemaitre's contributions must be situated in the second crucial period in which the basic framework of modern cosmology was established. Lemaitre himself traces his interests to science and cosmology to his childhood, which he spent in the south of Belgium. Unfortunately, World War I intervened, and together with his brother, he signed up to join the Belgian army to defend his country. After the war, he entered seminary for the priesthood, and he was ordained as a priest in 1923. While at the seminary, however, he was granted special permission by Cardinal Mercier to study Einstein's new theory of relativity. And he wrote a dissertation while at the seminary on the early applications of relativity to cosmology. On the basis of that dissertation, he was granted a travel grant to go study abroad. And that was the beginning of a unique scientific adventure for Lemaitre. His first destination was the University of Cambridge, where he deepened his knowledge of relativity, studying mainly with Arthur Eddington, one of the foremost astronomers at the time. Later, Eddington would write that he found in Lemaitre a truly brilliant student, wonderfully quick and clear-sighted, and of great mathematical ability. And coming from Eddington, this is really saying something. Lemaitre's next destination was Harvard and MIT. He spent a year in America visiting the major US observatories at a unique time in the history where the first observations were coming in that would challenge the age-old idea of a static eternal universe. In particular, Lemaitre was present at the American Astronomical Society meeting where Russell announces Hubble's discovery that spiral nebulae are in fact other distant galaxies. In other words, the universe was much, much larger than was at the time assumed. Lemaitre also, for the first time, works on cosmology. In particular, he studies the redshift in Willem de Sitter's universe. But de Sitter's universe was empty. There are no galaxies in de Sitter's universe, and there are no observers. Therefore, Lemaitre abandons this model. After that year, he returned to Belgium. He takes up a faculty position at the Katholieke Universiteit Leuven in the physics building that you see there. But he continued to think about cosmology, and he continued to think in particular whether relativity, whether Einstein's theory could somehow accommodate the latest observations showing the reddening of the distant nebula. In other words, can relativity be compatible with the observations? Is there a universe which is somehow in between Einstein's static world, which has matter and galaxies, and de Sitter's empty world, in which you would find a redshift? And Lemaitre's stroke of genius then is to abandon the notion notion of a static universe. And he does so in 1927 in this paper, which he chose to publish in a low-impact Belgian journal, written in French. And in this paper, he establishes the fundamental connection between Einstein's theory of relativity and cosmology. In particular, he finds a solution of Einstein's theory which interpolates in time between Einstein's static universe in the far past and de Sitter's empty universe in the far future. So on the horizontal axis you have time, on the vertical axis you have roughly the size of the universe. So that was the first model of an evolving, of a dynamical universe put forward. In the same paper, he establishes that if our world were like this, then we would indeed see distant galaxies shifted, the light of distant galaxies shifted to the red. And he has an equation, equation 24, in which he explicitly derives what later would become known as the Hubble law. Evidently, the data to support his prediction were very scattered, were uncertain. Lemaitre, in a typical sort of pragmatic, low-key manner, simply takes the average redshift and the average distance and divides between all the sample of the entire sample of galaxies and arrives at a specific number for the expansion rate. Now, Lemaitre's idea of an expanding universe did not go down very well with the scientific community. In fact, later in 1927, he meets Einstein for the first time in the margin of the Solvay conference in Brussels, where Einstein tells him, well, your calculations are correct, but your physical insight is tout à fait abominable. As you know, 2 years later, Hubble establishes observationally, with more precise data, the linear relation between distance and redshift. And at that point, evidently, the scientific community is very much aware that there's something serious at stake for relativity. Therefore, the reddening of the nebulae is very much high on the agenda at the January 10 meeting in 1930 at the Royal Astronomical Society in London, where both Eddington and de Sitter really put forward the pressing issue whether relativity can be made compatible with Hubble's observations. It is only at that point that Lemaitre reacts and writes Eddington saying that he had found a solution to this problem 3 years earlier. And on the right you see the manuscript that Lemaitre sends to Eddington, which Eddington passes on to de Sitter, and Eddington writes a little note in the top left corner saying, well, this seems to be a complete solution to the problem we were discussing. And from then onwards, Eddington, de Sitter, the whole astro-relativity community is very much on board with the idea of an expanding universe, and eventually also Einstein concedes. But whenever one is on board, Lemaitre is already one giant step further. These are the first known sketches of Lemaitre's dynamical universes. And you see a whole range of universes there, some of which expand and then contract, others keep on expanding. But they share one feature, which is they don't have an infinite past anymore. Meanwhile, while the scientific community was getting used to the notion of expanding universe, Lemaitre had just excised Einstein's infinite static past from his model of cosmology and replaced this with a genuine origin. You see that if you go back in time on that graph, the universe gets smaller, and because time is welded to space in relativity, you arrive at a genuine origin. In a way, Einstein's relativity, when extrapolated backwards in time, predicts its own downfall. It predicts, as Robert was saying earlier today, that there is a singularity. Now, what does that mean? We don't really know, but one thing we do know is that our usual notions of space and time no longer apply. Overall, I think you can say that in these early days of the discovery of the expansion of the universe, Lemaitre, much more than his contemporaries, embraced the notion of evolution. Cosmic evolution was just much more central in Lemaitre's thinking than anyone else at the time, I believe. Now that beginning, well, here's another quote of Lemaitre, so he compares that origin, he compares space-time to an open conic cup. The bottom of the cup is the origin of atomic disintegration. It's the first instant at the bottom of space-time, the now which has no yesterday, because yesterday there was no space. That's a prime example of Lemaitre's semi-poetic way of doing science. And so he called that beginning primeval atom. And in fact, he set out his vision of the origin of the universe most clearly and perhaps most visionary in a small paper which he published in Nature in 1931, called The Beginning of the World from the Point of View of Quantum Theory. This paper is very gently, very carefully written, almost poetic, and in fact it's assigned in his own name with his home address, not his university's address, and it's written as a response to an earlier statement made by Eddington a couple of months earlier, which I'm showing at the bottom there, where Eddington essentially claimed that any notion of the beginning of the world is repugnant to him. Lemaitre, in his small Nature paper, offers a resolution to Eddington's. So Eddington's reasoning was that, well, if you go back to the beginning, then surely this is going to require an infinite amount of organization to get the world going in just the right way. Lemaitre offers a resolution to this problem by appealing to quantum theory, by appealing to the uncertainty, to the indeterminacy of quantum theory. Lemaitre was looking for a natural physical beginning out of which a complex cosmos could conceivably emerge. And that is exactly what current inflationary cosmology in fact is implementing. Another thing which is important to realize is that above all, for a beginning for Lemaitre was also a kind of frontier as to what is the region of the universe, what is the realm of reality with which we can have any observational contact. So in a way, his primeval atom is also a sort of attempt to specify a kind of horizon in cosmology, beyond which we cannot have any observational access. Interestingly, Lemaitre realized when he was going to evoke quantum theory that he was not going to get a unique world. He ends this paper in the following way. Clearly, the initial quantum could not conceal in itself the whole course of evolution. The story of the world might not have been written down in the first quantum like the song on a disc of a phonograph. Instead, from the same beginning, widely different universes could have evolved. So that's a precursor, really, of modern quantum cosmology or modern multiverse ideas. Now, you will not be surprised after hearing Einstein's reaction to the expanding universe that Einstein wasn't keen on the notion of a beginning. After all, it implied the breakdown of his own theory. And indeed, Lemaitre and Einstein had a lot of correspondence in the early 30s, but Einstein would very much keep any notion of a beginning at a distance. In fact, he complained to our Belgian priest that this reminded him too much of the Christian dogma. But here we have a Belgian priest trying to make clear that religion and theology is very different from describing the physical origin of the universe. And incidentally, the paper that I'm showing there ends with those words. But at the archives of Lemaitre, you find the manuscript of this paper. And the manuscript of this paper contains an additional paragraph, all the way at the end, which Lemaitre crossed out before publication. And there it is. So all the way at the end, Lemaitre writes, "I think that everyone who believes in a supreme being, supporting every being and every action, believes also that God is essentially hidden, and may be glad to see how present physics provides a veil hiding the creation." Here you clearly see that Lemaitre's analysis, Lemaitre's insistency that the physical origin of our world should be part of science, which is the key point of this paper, is distinct and compatible with his theology. In fact, a constant theme in Lemaitre's theology is the reference to Jesaja's Deus absconditus. So what he means by that veil is really, is to make a distinction between physically describing the emergence of notions of space and time versus asking transcendental or metaphysical questions. He maintains that position clearly for the rest of his life. And here is just an example. In 1958, when he chairs the cosmology session at the Conseil Solvay in Brussels, he writes, "The hot Big Bang model is nothing but a scientific hypothesis to be verified or falsified by observations, and remains entirely outside the realm of metaphysics or religion." He is very clear on this constantly, and in a way I believe it also provides some of an understanding of his activities as president of this Pontifical Academy of Sciences, where he carefully and meticulously maintained the autonomy of science and religion as two harmoniously coexisting spheres, distinct in their methodology. He also, I believe, presided over a significant broadening internationally and as far as discipline is concerned at the Pontifical Academy. Does this mean that philosophy has absolutely nothing to say about cosmology for Lemaitre? I think the answer is not at all. Lemaitre never attempted to make any conceptual link between the two, or never provided any theoretical bridge. But clearly his life and his actions very much reflect a unity between these two dimensions of his life, what he would call two ways to the truth. So you're not going to find any official or public statement about any link. But look at his diaries. This is one page which I took out of his diary. On the left page, you see a description of his favorite cosmological model, an expanding universe, and so forth. On the right page, there is a discussion of, in fact, a medieval Flemish spiritual thinker. These two aspects of his life are constantly intertwined in his diaries and really make Lemaitre, through his actions, who he was. Now, in the early 30s, Lemaitre and many other people at that time, Tolman and so forth, consolidated that early picture which would become the foundation of our modern Big Bang theory. Interestingly, Lemaitre settled on this particular model of cosmology. A universe, in other words, which expands fast, initially, which then goes through a slow period of expansion, and finally accelerates again. Beautifully visionary, and as Saul told us, it turns out to be the universe in which we happen to be. It's also interesting why Lemaitre settled on this universe. Because you might think, well, it's not the simplest universe, and indeed this is a little more complicated than what you might have wished for. Lemaitre settled on this universe because he thought there better be enough time for galaxies and stars and planets and complexity to develop. In order to have enough time, given his value of the expansion that he could measure, that Hubble found, he needed this flat plateau, he needed that decelerating phase in the middle. So Lemaitre reasoned, and this is pure Lemaitre, this is really pure Lemaitre. Lemaitre reasons here in a sort of subtle magic sphere between theory on the one hand and the obvious fact that we have to exist in the universe on the other hand. He sort of naturally takes into account our existence in these very early models of the universe which he built. Now, that final phase of accelerated expansion that you see there is realized in Lemaitre's model by the cosmological constant, little lambda at the time, which Jim and Sol already told you about. Lemaitre kept this. In contrast to Einstein, Lemaitre always kept lambda, and he regarded lambda as a bridge between relativity and quantum theory. In a way, he regarded lambda as sort of the ultimate connection between the infinite small on the one hand and the infinite large on the other hand. Which may well be true. Lambda, we now have observed the cosmological constant. We don't really know where it's coming from. But it might well be, in my opinion, that with a better understanding of quantum gravity, that this understanding of quantum gravity may tell us something more about this cosmological constant. Put differently, we may already have made an observation, namely the value of the cosmological constant, which tells us perhaps something about the true quantum origin of our universe. So to sum up, what are the key ingredients of Lemaitre's hesitating universe which he settled on? It's an expanding universe with a cosmological constant and a quantum origin. That, he concluded, should come with some relic radiation. There should be, in his words, some fossil radiation left over from that very early hot epoch of the universe. And I let that describe to you by himself, if the movie can start. Here is a little part of an interview he gave.
Évidemment, on peut s'attendre à ce qu'une partie de ces rayons ait échappé à ce processus de condensation. Et là, nous avons un élément différent peut-être dans la théorie de l'atome primitif, c'est que une partie des rayons ont échappé, ne comptant presque pas d'hydrogène, et que ces rayons peuvent se retrouver, et que l'on peut espérer qu'ils se trouvent, dans les rayons cosmiques. C'est une théorie qui a été avancée non seulement par moi-même, mais par Wegener il y a bien longtemps, qui appelait les rayons cosmiques des rayons fossiles, en ce sens qui sont des témoignages des tout premiers âges du monde, et que pour ma part, je préférais appeler les rayons du feu d'artifice primitif, qui se sont conservés dans l'espace remarquablement vite et nous parviennent en nous témoignant, en nous donnant un témoignage des premiers âges du monde. Évidemment, un peu de poésie là-dedans.
So he talks about the fossil radiation left over from the early primeval stages. That interview was recorded, we believe, in 61 or 62, before, evidently, the discovery of that fossil radiation. Lemaitre settled on this model of cosmology around 34, 35, and then never really worked again on cosmology. In fact, he did other things. He became pretty much obsessed with computing, and he established the first computing center in Leuven. And then he also famously turned down a huge grant from the US Department of Energy to expand that computing center, because he was never interested in building up big centers. In any case, his model of cosmology was essentially observationally vindicated by the discovery by Penzias and Wilson of the background radiation and the cosmological interpretation given by Jim Peebles and his colleagues. Lemaitre learned about that discovery a mere 3 days before he died, a colleague of his visited him in the hospital, and he replied, "Oh, je suis content, maintenant on a la preuve." Thank you.
Thank you very much. We are a little bit over time, but it's a very good conclusion for this Lemaitre session. We still have time for a couple of questions. Yes?
I have a small remark and question. Remark is following. You know that in our library of this academy, there is a preprint or booklet of Dirac about Lemaitre. And the commemoration of the Lemaitre was made by Dirac, greatest physicist. And the question is following. What this happened with the Hubble constant, this history? Why it disappears in the translation? One may not notice. What is the status now?
Okay, so I should provide a little context. The question is, Lemaitre derives a value for the expansion rate in his 1927 paper. In 1930, Erikton asks Lemaitre to translate his paper into English. But the translation did not contain the derivation of what became known as Hubble's constant. Lemaitre did not find it useful to translate because in the intervening years the data had improved, and so he replaced his derivation, which was based on sketchy data, with a reference to Hubble. Lemaitre not being interested in self-promotion.
Translator was Eddington, yes?
No, Lemaitre himself translated his paper. This is known from a letter that he wrote to the editor at the Royal Astronomical Society. That letter was found last year.
I am curious about the primitive atom concept. That concept was coined by Lemaitre, and then it turned into Big Bang. So did Lemaitre do anything to maintain his initial primitive atom concept?
I do know he didn't feel that the term did justice to his model, and in fact I think in the interview he says here he would call that rather a primeval atom. But okay, these are terms stick.
Thank you and congratulations for your very nice presentation.
Thank you.
But who was the theologian medieval that you put in the second page that you say you can see here one page about the question of cosmology and the other page about discussion of medieval theology? Who was? Because as you know, we have two traditions. The tradition of San Bonaventura that say we can prove the temporal beginning of the creation, and the tradition of Thomas Aquinas that is more important.
Yeah, so Lemaitre was clearly much more oriented towards the second tradition. Sort of a much more two distinct levels of reality.
For this reason, I think that he don't have, sorry. There are many microphones open. Thomas Aquinas said that it's impossible to prove the temporal start of the creation. The creation is a philosophical question that we can demonstrate with some philosophy, that is the beginning of the participating being, from the first cause of the being that is God. But this is a philosophical, it's a question of being. That is not a question of physical being, it's a general question of being. And for this tradition, he can have any problem with the theology of the church. And I don't think that he have problems here in the academy, as you said.
That's right. Yes, I completely agree. Yes. Yes. Loosely speaking, Lemaitre would have said that the existence itself of the primeval atom, or the existence itself of reality in a very abstract, non-temporal way, was distinct from the physical emergence of our classical notions of space and time. That's the point he makes in this very short paper. I think it's crystal clear, and in fact one might say, and now I'm maybe on a slippery slope here, but one might say that it is precisely Lemaitre's training, both in science and in philosophy, that allowed him to see that frontier a little more clearly than his contemporaries. Someone like Einstein would just not go there. And I think it's just because he didn't see that separation very clearly. But to answer your previous question, this is Ruysbroek.
Robertes.
I was just wondering if you or Monsignor could comment on Lemaitre's contribution to this academy, because it's a source of immense pride that he was the president of this academy. And maybe of some his religious viewpoints.
Well, I'm sure others here can say more about that, but from what I understand, so he became president during the Second Vatican Council. He had been a member, I believe, since its creation in 1936. And during his presidency, I can see clearly that he was very careful about the safeguarding the autonomy of the Pontifical Academy. So he did feel, I believe, that this should be a forum, a platform, where one can freely and openly discuss about anything, and that a dialogue with the religious sphere would then naturally coexist with that. So in a way he implements in his presidency, as far as I can tell, the same kind of vision which he implemented as a cosmologist in the 30s when he came up with the idea of a primeval atom. That's somehow a little bit how I see the connection. Secondly, this is also very important, I think, and he was well known in Leuven, in Belgium, to be extremely open-minded to people from all walks of life. In that context, I think you can also see the second important activity of Lemaitre at his academy, which is he internationalized it a lot, and he invited scientists literally from all over the world to become members. So I think you must probably know this better than I do, but that's... So, an interesting anecdote is during the Second World War in Belgium, the University of Brussels, which was not a Catholic university, was bombed. Lemaitre immediately went to the Chancellor of Leuven to say, we should invite the students of Brussels to come to Leuven. That's not so special. But he added immediately, and we should exempt them from all courses related to spirituality or religion. We should keep an open mind. That's typical Lemaitre.
Thank you again for this presentation.